Hello. As always, having technical difficulties trying to get started today. Welcome, everyone, to this edition of streaming about learning TensorFlow.js. I just want to get started by saying if anybody has good jokes, always feel free to leave those in the comments because they are welcome 100%. I like jokes. And even if they distract me, they are good news for me. So this is Tuesday, I think. I feel like the last 2 weeks have been one single year in 2 weeks. So I'm proud of myself for knowing that it is Tuesday. If you have a Tuesday joke, leave me a Tuesday joke. So what are we even talking about today? Last week, well, let me tell you who I am first of all. I'm Becca. I've been doing this. This is my 6th live stream, which makes me really excited because we are more than halfway through all of the live streams on TensorFlow.js, which kind of blows my mind. So we've been doing this 6 weeks straight, and I'm learning how to live stream while I'm learning how to do TensorFlow.js. And I have to say, I'm feeling a lot more comfortable than I was the very first day. So that is really good news. And I am happy that I am feeling better about all of this. And so we're going through Gant Labord's book, Learning TensorFlow.js. I'll go ahead and drop that in the chat. And it's been really great. So I am the creator of a developer group called Virtual Coffee. I'll drop that link in the chat too. And Virtual Coffee is a group for developers at all stages and all backgrounds. So we're tech agnostic. We meet 2 times a week, Tuesdays and Thursdays. So we met this morning, and the topic that we were chatting about in my breakout room was learning goals for the new year. And I was just saying how great it is. There are 2 things that have really helped me in this learning experience with TensorFlow.js. And the first thing has been having a curriculum to do that, because it can be really hard to try and learn something when you aren't really sure where to start or where to end or what should go in the middle. It's kind of like my background is in writing, and it would be like trying to write a movie, but you don't know what happens and when it happens, and just kind of like mashing that together with different storylines. You don't want that. You don't want multiple storylines. That only ends badly. But I have learning TensorFlow.js. There you go. You can see it. There's no glare there. From Gant Labord. I'm sorry, I accidentally gave you the finger. That was unintentional. And we've been using this for all of the streams. And so through 11 or 12 streams, we're going to be using that and going along with the curriculum, because it breaks down the ideas in really nice ways. And it gives us some problems. So I'm going through a lot of the models that he talks about in the book, but also there are challenges at the end of every chapter. So if you are interested in it, I say go for it. It's really been great for me. So I would say if you're learning something, having a curriculum that you can kind of follow along with eliminates the stress of having to piecemeal your own learning experience. And the second part of that, of what I think it works really well, is having accountability, at least for me, because I don't know about you, but I feel like I know at least 50 people who have bought lots of $10 Udemy courses or free Udemy courses and have not finished. It could be the quality, but it could certainly be that there's not a drive to finish it because you don't have accountability. And so we've been doing a TensorFlow.js small group study group on Fridays at 1 p.m. Eastern. So if you're interested, just let me know. You can hit me up on Twitter. I'm at Becca HW everywhere. I will go ahead and throw that in the chat as well. And I am, so we're doing that. And that's been really helpful because we can talk about things together. We can ask questions. We can give examples. The next 2 weeks we have people presenting their projects, which is nice because I think that practical application is super important. So Definitely find ways that work best for you, but I really appreciated being able to talk to other people at Virtual Coffee this morning about things that work for them, and doing this journey. Image recognition for post-it notes. Nick recommends that. So I'm not sure what will we be recognizing with those post-it notes. Do you just want to zoom in and see what they say? I'm trying to see. Wait a minute. Oh. Don't zoom into that one. That was one my kids wrote. Okay, you can see the 3 pink ones. Well, this one is done. That's for RubyConf. That's over. Those are the talks that I've done. One of those talks, I can cross it off. My second talk is on Cypress, and I've got one coming up. Both of them, I think, are in January. Hopefully. I'm working on that talk this week. And let's see. All the things that I want to work on for the rest of this year. Pairing challenge, that came out of Virtual Coffee this morning. So we do monthly challenges, and we are doing a monthly challenge in January. No, January is not pairing. January is month of learning. So we're getting together and learning with each other. And then I think maybe February is pairing challenge. Anyway, so post-it notes are my thing. I like post-it notes a lot. They help me to remember. Even if I don't look at them, it's physically writing them down really helps me to remember what is going on. So, all right. I have talked for a long time and never hit enter on my Twitter. So, now I did. There it is. And I think that's a good enough intro for me. So one of the things that we're going to be talking about today, we're going to be talking about Mobilenet. Last week we worked with the Inception model, and both of these are classification models. So you're looking at images and you're classifying those. And today we'll be drawing bounding boxes around our images, hopefully. So a bounding box is when it identifies an image, when it classifies an image, then it will draw a box around it, and then we should be able to label what that image is. And so the difference between the Inception model and Mobilenet is that the Inception model, I think, has 1,001 classes, while Mobilenet has 80. And so I bet you could probably guess what the difference between the two is. Mobilenet is faster and less accurate than Inception, but Inception is more accurate and not as fast. So recognizing that, I think, is useful in trying to figure out which model you would want to use. And in the book, Dan talks about when you're using these models, when you're learning, I think it's like, whoa, that's really cool. We can identify 1,001 things. But if you're thinking in practical use cases for this, when people are using the models, they probably don't need to identify 1,001 different things, right? You don't need to identify an axolotl and a tiger and a pencil. Those things don't really overlap. So if you're thinking about using one of these, think about, what you would need it for. And for a lot of us, it might just be a handful of things or less. And so finding one that is faster, or working with something where you can shrink that class size and train that model to detect specifically what you want is important. And so we're going to talk from there about the difference between the layers models and the graph models. And this is something that I was really confused about, and we talked about on our during our study group on Friday, the difference between these two models. So you load them differently. And so you load, let me see here. I've got links for it here somewhere. Here we go. Okay, so load graph model. Here is that entry. And then I think this is load layers model. So you have these two different ways of loading models. And so you can pretty much guess which one you want to use. And somebody said, I'm not sure if this is accurate because I did not fact check it, but they said that when you're loading from TF Hub, where a lot of models are hosted by Google there, that they're always the load graph model for TensorFlow.js. So far, everything I found there has been load graph model only. So I'm not sure if that's accurate. But if you try to load a layers model with the method for load graph model, it's not going to work. So if you're not sure, you can try either way. But I wanted to understand a little bit more, like what is the difference here? And so what we talked about in that study group was the layers model is something that you can manipulate. It's something that you can optimize. It's something that you can build on. So you have these different layers that are applied as part of a function. And you can apply, several layers. Imagine that you're looking for one particular object. I cannot think of anything off the top of my head right now, but if you then you can optimize it by adding different layers of classification or what you're trying to identify there. And so that's a trainable model. And so when you do that, it can be more accurate for what you're looking for. Sometimes it's not nearly with more layers, it will be harder to optimize, and you're going to need more training. So if you want to add, think about like each layer probably needs some sort of training to it. So you have to continually add that to optimize it. But it's more versatile because you can train it. You can add things to it. You can expand upon it. And my understanding, and if you're in the chat and you know that I'm wrong, please tell me. But my understanding of the graph model is for TensorFlow.js, you can't fine tune it. You have to use it as is. Okay, so whatever you're looking at for that model, what they give you, what you see is what you get there. But it's often optimized and can work quickly. So there are certainly trade-offs there. Okay, so then we're going to bring in the Keras model. So the Keras model is, my understanding is, it's a wrapper on top of TensorFlow. And it was introduced in TensorFlow 2. And so this allows you to create the layers, I believe. And so my guess is, which again, did not fact check this, my guess is that graph models were being used first. And as we were integrating Keras models into TensorFlow.js, that allowed for the layers to happen. Now, I do believe that you can load Keras models depending on how it's transferred over into TensorFlow.js with either the graph model or the layers model. So I think that's how that works. But what you really want to do is figure out, like, how did this model originate? And then that can help you determine, what you can do with the model, what's going on behind the scenes. Oh, and I've got this, actually, I think Nick, who is here now, dropped this link in our study group about the difference between the two types of models, and that was super useful for talking about these things. Let's see here. So maybe I will share my screen now. Let's see here. Okay. So what we're looking at now, this is the model that we're going to be working with today. And so there's a couple of things here. So we're working from TF Hub. And so this is, again, where Google hosts a lot of the popular models that people can use. And we're working with SSD Mobilenet version 2. Now, what we want to do, okay, so there's a couple of things here that I just want to point out because I feel like as we're learning these things together, it's really useful in understanding, what we're actually getting into. And so we can see the data set here is Cocoa 2017, and I think there's about 80 classes for this data set. Okay, so if you click that, these are all of the other models that are using that data set as well. And it tells us where this comes from. Now, if you click here, this gives you a little bit more information. So this is TensorFlow. We're using TensorFlow.js, so this is not going to be what we want to use here. We're going to be moving over here, but I just want to take a second to look at this. So it says fine-tunable, no. And I believe that if it's not fine-tunable, then you're going to be using load graph model because it's not something that you can change or, add to that, add layers like we talked about before. And you can see a little bit more about what they're looking at. So here I talked about bounding boxes before, and they're drawn around all of these different objects with the labels, and they're identified in different colors, which is pretty cool too. And so that's what we're looking for. This gives you an example of how to load it and what you're going to be looking for. So when we go into that tab for the JS portion of this, it might not have all of this information, and so you might have to go back and forth to kind of identify, like, okay, what do I need to look for here? What do I have access to when I'm utilizing this model? So now let's go ahead and take a look at what they have over here. So again, it tells us it's not fine-tunable. And what I have found is sometimes when you're in the TensorFlow, it will say fine-tunable. And then you go to the JS portion, the JS tab, and it says it is not fine-tunable. So again, just some things to look at when you're trying to understand these things. It gives you the URL if you're going to be loading this model here, so you'll want to copy that. Tells you what it's based off of. If you want to import it, that's how you can import it and run it. And there's more documentation there. So that's a little bit of an overview about what we're going to be talking about. I do have this code sandbox that we'll be working along with, and I'm going to go ahead and drop that in the chat now. But I also want to say, like, there's a couple of more things that I think are worth noting here before we jump into this. So we are going to be using load graph model today. I am pretty sure, yes. I said that and I was like, wait a minute, are we? Yes, we are. And we're using SSD Mobilenet. So what does SSD even mean? It stands for single shot detector. And so that means that it's trying to identify image features as a whole. And so this allows it to be pretty fast. And there are two components that I think are important to understand for an SSD model. You have the backbone model, which means it knows how to recognize models, and the SSD head, which localizes the objects. Okay, so what does all this mean? Why is this important? Well, it's good in that Mobilenet is fast, it's friendly, it's fairly easy to figure out what you're doing as you walk through these things. And Mobilenet and SSD get combined through this thing called control flow. This allows us to conditionally run operations in our model. So here we're going to be using execute async here. We're going to have to be using asynchronous rather than predict, which is a synchronous method, because it won't work when you use control flow. So that's something to note too. Let's see. What else? I think that's good enough to go ahead and get started and figure out what exactly we're doing here. If you have questions or you have comments, feel free to throw them in the chat. Again, if you have jokes, I am here for jokes all day long, so put those in the chat too. So here, what do we have going on in this example? Use my Control B to get rid of that side panel because I have everything open that I want. So the first thing that we need to do is we need to load the model. So again, we're using this load graph model here, and we are using the link that we saw over here, copy URL. So we've got that. The model is loaded. Excellent. We have done something. And step 2 is going to be to get the image. And so let's go back over to the index.html. I've pretty much been using the same index.html for every code sandbox I've done since the second or third live stream. So we've got that going on. I have a mystery image. Last week we used the lobster, and this week we've got some people who are there. So we're going to go ahead and try and work with that. So I've loaded that from Unsplash. My ID is mystery. Yesterday I kept mixing up my words in the entire day, so it's been hard for me to. My 12-year-old asked me yesterday. He said, "Can you not word out of your mouth hole today?" It's true. I am wording a little bit better out of my mouth hole, but still not optimized. So somebody needs to upgrade my model apparently. So we have this. We've loaded it. We're grabbing it here, and now we need to. I've got a lot going on here. Wow. Anyway, so I guess I've done a lot of pre-work that I forgot about. All right, so we got the image. We're going to give the model an image in a usable form. So if you remember from last week, we have to use this from pixels. And so if you want to go to the API, you can look all of this stuff up from pixels. All right, and so it creates a TensorFlow, a TF tensor from an image. So we can't just use an image with TensorFlow. We have to take an image and we have to convert it in a tensor to put it in a usable form. And so that's really what we're doing here. We're taking that image and we are converting it to a tensor. And so we've got this expand dims, and I really like Code Sandbox, gives us these nice little things. What is this called? Again, wording is not working for me. It returns a tensor that has expanded rank by inserting a dimension into the tensor shape. All right, so basically what that means is we've got to do this stuff, and they're going to do it for us right now. And so we're passing it that tensor image there, and let's see. We're going to try and get usable results. Okay, so remember like 3.5 minutes ago, I said that we're going to be using async because we can't predict right now. So we're going to go ahead and console log the number of detections. So we're going to go ahead and do results.length. And I feel like I'm running through this. Well, my console has a lot of stuff there. So let's reload this and see what happens. Nothing in the console. Perfect, but there are problems. So classes is defined but never used. I know I didn't get there yet. Okay, and then I do this thing where I can't make this bigger because that is so hard. Here we go. Boxes is assigned a value but never used. Yeah, we're not there yet, but okay, console, finally. Number of detections, 2. Okay, so we know that there are 2 detections here. And let's see, I'm sorry. Let's go back a little bit further because we have these labels, and I said that there are 80 of them, but I didn't say what they were. So I did drop that link in the chat earlier, but if you want to look again, here's our list of all of these different things. So person is one of them. I sure hope that we identify a person here. I don't see a lot of these things. Cars, motorcycles, birds, benches, cows, elephants. Unused is twice. That's good. Snowboard, sports ball, surfboard, bowl, spoon. Is there like a glass? Wine glass. We should have a wine glass identified, but it doesn't have a stem in the wine glass in the image. It probably would be useful to be able to see the image too. Okay, so we do see a wine glass. There's a wine glass. There's a blurry wine glass. So there's certainly some wine glasses there. They're a little bit like obfuscated from the view with other things and with the blur. And that's been something I've been really interested in, the quality of the images that are used as we work through this. Okay, I could see that seems, there are 3 people, but we only see one person's head. So it would be hard to identify people there. All right, not bad. We can always pick a different one too if this one does not work. Okay, so we have 2 number of detections. Let's go ahead and just see what the results look like, just because I always like to see, all right, what exactly are we looking at here? So we'll go ahead and say results and just do results. Oops, delete that. We're going to comment this out because we don't want to see that. And we're going to give it a second. Let's make this console big again. Woo, here we go. Okay, so here's the first one. We've got 2 arrays. And we're looking at right here. It gives us different types of things. We have a rank type of 3. We have a shape, which is an array of 3. It is not going fast for me. With the float 32. Okay, so we have all of these things that are useful to know. Those are really the most important things. So we know we've got stuff going on there. I'm going to try and shrink this again. Here we go. Cool. And what else okay, so now what do we have going on? What can we be doing here? Well, we are model.execute, async. We console log the results, but we can just delete that. We don't need that anymore. Whoops, tried to delete that whole thing and it did not work. Okay, so now what we want to do is we've got this canvas in our index.html file. And so this is where we have, okay, so we're going to look at this. And then on our canvas, we're going to have bounding boxes, hopefully, around the classes that have been detected. So, okay. Yeah, I did a lot of pre-work here. I just totally forgot about this. I must have done this at the beginning of last week. Okay, so prior to working with TensorFlow.js, I hadn't really used Canvas or get context or anything. So for me, there was a lot to learn, not just about TensorFlow.js, but about working with canvases and what we could do with them. And so I think I have some, oh yeah, I have lots of resources here. But I think we're going to be, the first one that I'm going to drop is we're going to get context right here, CTX. I'll go ahead and drop that in the chat because I wasn't exactly sure what that meant. And we'll just take a look at it real quick so we can talk through it a little bit. So when we get context here, oh, that was nice. It made it nice and big for me. It's a method that returns a drawing context on the canvas if the context identifier, blah, 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 or the canvas has already been set to different context mode. Okay, so canvas.getContext and then context type. And so what we have there is 2D, leading to the creation of a canvas rendering context 2D object representing a 2-dimensional rendering context. So there's more information about that there, but I think that's good enough for now. Okay, so we've got 2D, and then we want to draw the image. I think that this is not going to work, but we'll go ahead and see what we've got going on here. I clicked run because that should happen, and it does not work, just as I predicted. Okay, so wait a minute. Oh, and I deleted my... Okay, so what should be happening is when I click run, something happens, but it's not, nothing, because right here I have run code, I have an event listener, nothing is going on there. So clearly I did an excellent job of just stopping in the middle of what I am talking about here. So, okay, so we're drawing this image. We have a font. Okay, so what is the font? You're like, okay, we're looking at images. Why do we need a font? So ultimately, what we want to be doing is drawing these bounding boxes and labeling them. Where did we see that? Was it here? Yeah, I think here. So the font would be this, Kite, 77%. That's what we're trying to draw here. And so we've got, that's what our font is doing. We're grabbing our image width, image height, detection dot width. Okay, so detection is our canvas. So that's the variable that we have used for canvas. These are the things that we're doing with the canvas. And then what do we need to do next? Well, we actually need to go through and label the thing, right? So what are we going to do there? All right, let's do, okay, this is why. So it says, if you were here with us earlier, problems, it says that we're using boxes, but we aren't using it. This is where we're going to go back into using boxes. And so this goes back to the results that we console logged earlier. And I think that maybe we don't need to have that. Well, we're going to go ahead and see how this works out. Okay, so we're in here. We have console log check, which did not work when we clicked run. Interesting. Oh no, it did, but it said 0, so I thought it didn't. Okay, so we're good. We're here. We know that this is running, so hopefully it should not have very many problems. We're going to go boxes dot for each, and then box okay, so what do we need here? Let's go ahead and just console log box and see what that leaves us with. Okay, I think I've broken it. All right, here we go. Unexpected token at 48. What did I do here? 48. I feel like that's okay, so I'm gonna reload it. And this would be the time where I would give you our sponsorship message. But we are not sponsored by anyone, or everyone. And we certainly are not sponsored by Pepperidge Farms. Okay, console was cleared. So let's see here. Do we have the appropriate end of these brackets? Classes is defined but never used. Yes, I know that. But why are we not console logging things? Okay, nothing is happening there. Why is that keep? We're going to go ahead and console log boxes and see what happens. Absolutely nothing. Oh, wait, because I have to hit run, right? Oh, this is why. All right, Tuesday. There we go. Tuesday was just not having it. So we've got lots of things. I just forgot to hit the button that console logs the things. So there are boxes. So we're good. It just helps to do what you told the code to do. Okay, so we've got the boxes. We're looking at the box. Okay, so it gives us these 4 different points, I believe. And so from there, what do we want to do? We want to go back here. So we're still looking at this get context.2D. And we are going to try and draw these boxes now because we have nothing going on to the canvas yet. And so we have to get this image onto the canvas to be able to draw a box around that, right? So let's see here. We're going to need to draw it around the height, around the width, and we need to know the X and Y coordinates to be able to do that. Okay, so we are going to give it a, let's see here. All right, so we're doing this thing, right? Canvas rendering context 2D, and we've got, now we need a stroke style. Okay, so this is going to be how that box is actually built. So we can attribute it a color, a gradient, or a pattern. Let's go ahead and do, here we go. And here we're going to go ctx.stroke style equals, let's go with blue because it's my favorite color. We could probably provide it a hex value and that would be more accurate, but this is what we're going with now. We also need to provide it with a line width. So we can see it, ctx.linewidth equals, we're going to give that a 1, and that should be thick enough. And now we need to figure out, okay, so we know what color it is, we know how thick it is. Now we need to know where that box is going to be placed. So this is where the height and the width and the X and the Y coordinates come into play here. So we need to assign those to a variable so we're able to use them. So we are going to do, say, const start Y. So where is it going to start on the Y coordinate? And we're going to say, so we looked at these tensors. This is our Y1 here. So box, we're going to give this the first there times image height, which we set up here. Image height. Yes, there we go. Now the next thing you can put is the image width. While I'm doing this, if anybody has jokes, I've said it 5 times already, and this is the last time I'll say it, feel free to throw those in the chat while I type slowly. Oh, okay. Too much going on there. Times. Thank you, Nick. What do you call cheese that's not yours? I know that one. Nacho cheese. I feel like I beat you to it. I told you the answer. My 5-year-old yesterday wanted me to tell her a joke. I was so disappointed in myself because I could not think of any appropriate jokes to tell her. So she told me jokes. And I don't know if you have a 5-year-old, but they're still in that stage where they like grasp the concept of jokes, but they don't know how to tell jokes and they just think they can make them up. And so they say very random things that make no sense. and then they want you to laugh at them. I have 4 kids. I am like all laughed out at those kind of jokes. Okay, so now we need to go ahead and set the height of our box. Height of the box, not of the image, height. So we're going to go ahead and do this. My computer feels like it's taking off. I don't know what's going on. I did not shut down enough things, apparently. Box. It's working very, very slowly. 2 minus box 0. Okay, and if you look in the console log, you can still see maybe what's going on here. Okay, 2 minus box 0. So those are the y coordinates, I believe. Yeah, and then the next we'll do for the width, it'll be 1 and 3. Height box 2 minus box 0, and then we're going to multiply that by image height, because the y coordinate, yep, y coordinates go up and down, x coordinates go across. And then we're going to go ahead, and if my computer does not take off, we are going to go ahead. Oh my goodness, my computer is going so slow. Const width. We're going to basically just go, well, we haven't done yet, box 3 minus box 1, x coordinates there. It would help to have an equals. And then if you guessed, it was going to be times the image width. That's an @ sign. You were right. Image width. Okay, so we've got that going on there. And now we are almost ready to get some stuff going on here. And again, my computer is taking off. So let me see what I can do to maybe make this a little bit easier on my computer so we do not have to deal with this. So I was at the TensorFlow working group meeting yesterday, and we were talking about examples of different types of tensors or different dimensions of tensors. And so we were talking about a 6D tensor. And so I have not really explored what a 6D tensor would look like, but someone had mentioned looking up MRIs. And so they're doing like 6D tensors of the brain, which really blew my mind because, or 6D images of the brain. It really like got into a deep understanding of different parts of the brain, which is something that I am very, very interested in. Since I have a master's in English, of course, I would be interested in that. But it was like fascinating to look at some of the studies that they've done with different brain imaging and what they're able to understand by, breaking it into these different dimensions. So I think that it's really cool to, kind of consider what different things like that can look like. All right, my computer still sounds like it's going to take off, so I think that that's just the state of my computer right now. And we're just going to go with it. Okay, so we have width, we have height, and we need some other things here. What do we need? Okay, so we're going to do this thing called STROKE. Okay, so we're going to use the .stroke rect method. It draws a rectangle that is outlined according to the current stroke style and other context settings. So that's what we've been setting up. And like I said before, I am just like exploring how to use Canvas and the things to do with this. So there's a lot of learning going on in this section. And I think what's most important is just like being able to ask those questions. So what do you do with canvases? How do you work with them? What are the different methods that they offer you? Because I think sometimes our initial reaction is, yes, I can go ahead and figure that out. But there might already be a method built in that can help you get to where you want to go. So we've got that one that we're going to use. And wait a minute, I wanted to stroke down. So we need X, Y, width, and height. And those are the things that we've just defined. So it probably would have been useful to go there a little bit before here. But this is where we're at now. Maybe do CTX dot stroke rect. So we've got our start. What did it say? Start X. Is that where we're supposed to start with? X, Y, width, height. So we want to go start X. Oh, and it was not working. Start X, start Y, and then it said width, and then it said height, and what did I do wrong? Yeah. All right, let's save this and see. This is not going. All right, unexpected token, line 60. Oh, I think I have an extra. Yep, extra parentheses. Okay. So let's reload this. Let's run this and see what happens. Nothing. Oh, there we go. There's something. Okay, so remember we said we wanted the bounding box to be blue. We've got blue and a whole lot of that bounding box. And that's obviously not what we want because it's covering almost the same thing. So when you're working with bounding boxes, you want to make sure that you there are a couple of things that you want to keep in mind. Let's go ahead and clear this so we're not just a blue bounding box. But if you notice, there are overlapping. Oh, my mouse is doing something weird. I don't know if that's happening on my screen. I don't think it is. Anyway, so we have this wine glass here, for example, and it's in front of this person. And we have a person and a wine glass here. And so you can see that this is not a clear image. And so one of the things when you're thinking about data sets and working with different data sets, there are a lot of things that can affect your image identification. Things like overlapping, things like the resolution of the image or the shade of the image. So is there enough lighting? Was this taken on a really high quality camera for all of the images? Or is there a little bit of leeway about where you can go with that thing? So we're going to try and make this a little bit better so we can actually use bounding boxes and not just have a big square around there, and see what we come out with there. I do want to have time for, we're not going to be able to set up the access to the webcam, but I want to demo it at least because I do have that ready to pull up. So let's see, where can we go from here? All right. Okay. trying to figure out how much time I can work on this. I do have a repo that uses the Cocoa SD model. When I was on Learn with Jason, I demoed that and had those bounding boxes working pretty well. And so I don't know if I should just drop the link to that in the chat or if we should try and get this going a little bit better. I guess, there are a couple of things to think about when we are talking about this, and so maybe I should talk about that because that's important. There are these things called IOUs, intersection over unions, and this is part of that. If we have overlap, how to detect those different objects accurately. So they identify like how much of an object, how much of a like bounding box does an object share with another one. So like for example, if I have my phone and I have an apple and they are overlapping each other, how much of that is being overlapped? How much does the apple overlap and share a box with the phone? And so that's something that you can, so if they overlap right on top of each other, then the IOU is 1. The less they fit, the closer to 0. And so, I'm trying to find something. Well, that would not really work. I have a Nintendo Switch, which is like close. It definitely overlaps that iPhone. So this would be pretty close to a 1. And then as we move them out, it would get closer to a 0. So I hopefully that makes it a little bit clearer what I'm talking about there. But then we have this other thing here when we're dealing with images called NMS, which is non-maximum suppression. And that is an algorithm that is used with IOUs. And that will grab that highest scoring boxes and get rid of similar boxes with an IOU over a certain level. Okay, so if you set the IOU for NMS, non-maximum suppression, to 0.5, then any box that shares 50% of its area with a higher scoring box gets deleted. Okay, so if we're sharing, over 50%, which in this case, the iPhone would be sharing over 50% with the Switch, then this one is going to get deleted. Obviously, you can see how that could be a problem. If somebody is, like drinking from a tall glass, then they might be deleted from that image. So there's an enhanced version of NMS called soft NMS, and this is built into TensorFlow.js. So you can breathe a deep sigh of relief. You don't have to do anything very, very special or tricky with this. So it would be tf.image.non-max suppress with score async. And this gives support for that. And that will allow you to grab more of those things. So here we go. I'm just going to drop what I just labeled that as in the chat. So if you want to go ahead and look that up on TensorFlow docs, you can. So once you have that sorted, you can get your detections and draw bounding boxes around those different things. And your results are going to be an object with select indices, which is a tensor of the indices of the boxes that were within that, and the selected scores, the scores that correspond with that box. So, for example, like here, this has person, 70 is the score. Okay, so now what should we do? Well, adding a text overlay using fill text, the 2D context fill text method, which here we go, is here. Fill text. That's one word. Yep, this is what we're looking for. Okay. Part of Canvas 2D API draws a text string around specific coordinates, filling the string's characters with current fill style. All right, so we need text, XY, and max width. And here is the link to that. And let's see where we should work with that. All right, so we need to have the label. Okay. So we need to do a little bit and figure out what is being used here. I'm just trying to figure out, this seems like it's going to take a longer time, and I'm not sure if we have time to do this and the webcam model, but I really wanted to get some bounding boxes around things. So what I could do is see if I can use the code from the book instead and just go ahead and drop that in. I really don't want to do that. Well, let's see how far we get. And if we don't get far enough, then let's say 10 more minutes. And then if we don't get it in 10 more minutes, then we will just jump into the video and do a demo there. Okay. Okay, so what do we want to do? We want to do all of the things that we just talked about. Detection, we do. All right, so we want a detection threshold, which we just talked about. Wait, did we do detect? We have. Yeah, okay. Detection dot threshold. Which is that we're going to be working again with that overlapping stuff. Detection. We want an IOU threshold, like we talked about, but we need to okay. Nope. My goodness. Stop it. I don't want you to do that. Equals. Let's go with 0.5. And we haven't defined IOU. Whoops. These things need to be. can't, not only can I not word out of my mouth hole, but I can't, I can't type either. Ah, here we go. All right, why are you giving me red squigglies? It's already been declared. Oh, yes it has. Sorry. We don't need those dots there. My brain just put them there. For funsies, apparently. Okay. All right, and results dot. Okay, we have the box. All right, so now, Oh, sorry. I just keep going back and forth on this. I'm like, I know this is going to take way longer than 10 minutes. So what is the right thing to do here? I still don't know. There are ways to optimize this that we definitely can't get to if we try and get through this really quickly. And I don't know if it makes it worth it to optimize things or to maybe just write a blog post to finish this thing out. But let's see. How do we find detected classes? Let's see if we can at least label these things. All right, so what do we have here? We have the rectangle, but we also want the score and we want the label. So let's see if we can get anything going here. All right, we've got the classes. So we're going to go and say const detected. So again, I'm just skipping over some things. There are important things that we skipped over, and maybe that's what I'll write my blog post about this week. I've been doing blog posts to go along with these sections. Oh, wait a minute. I don't have an index right now. Where is... We did detection. So we have, yes, no, maybe, yes, detection is that. We need to have, detected class, classes, dot, detection. All right, let's see where we're going with this. We need a score. Did we do scores anywhere? No, we have not set scores. Label should be the detected class and the detected score. Well, maybe we are not going to worry about score. Let's just see if we can get these classes up there. Detected class. All right, what do we do with this detected class? Let's see what that looks like. Let's console log it. Give it a second. Oh, I have to hit run for this, right? Maybe. Undefined. Well, that's not good. Okay. So, console.log, classes. No, we can't do that. Okay, so we have the detected classes. Let's see, DETECTION. Oh, what is this? Okay, so the detection. Yes, that is right. This is what we labeled detection. We have classes. We can't just do that. So what do we need to do? We do need an index there. We need some way of recognizing where that is. Right? Detected index. Detected class. Classes. We need to know what value that needs to be looking at. Max. All right, what are results? We're at the 10-minute mark. Severely underestimated how long this was going to take me to try and regroup here. Okay, results, one, squeeze, array. We've got the results. And then results one. Okay. Okay, what do we have going on here? Okay, so we've got our tensor with our results. And what? All right, let's see. Do we get here? Nothing. It says don't even think about trying that. Ah. No. Really, my computer's working against me now. It's like, you need to stop. Okay. Oh, okay. Interesting. Okay, so if we use top K, then we get the values. And the indices. Okay. All right. Let's see. Okay, so what do we need to be doing here? We need to be moving on because I need to wrap this up before 2:30 to get some kids. But this is where I'm going to stop. Maybe I'll do another stream and figure out the rest of these bounding boxes. Either that or I'll do a blog post about how to integrate that. But I did want to go ahead and move on to image detection with the webcam. So let me see. Let me go ahead and get this pulled up. And yes, it says it will not work. Even though it was working yesterday. So give me a second, and maybe we'll have something cooler that I can show you in a second. At least I found it cool. And it's less of me staring at the screen with a scrunched face. All right. Okay, so this is from Gant's example in the Learning TensorFlow.js. And so here we go. Okay, so this is interesting. So obviously my face is very, very bright right now. And so one of the things, let me turn it down. Maybe. Definitely knows I'm a person. Okay, woo, that's too dark. I'll lighten it up a little bit. Keep going a little bit more. I want it kind of dark just to show. So I was playing with this yesterday. And so, all right, let's see. Well, let's hold it over here. What is this? So it keeps flashing. It's a person, which is interesting because, oh, look, it's a donut. It keeps thinking things that I put by my mouth are donuts. And I don't know what that says about me, but I really don't eat that many donuts. Or like it was yesterday, it was either a donut or a banana. Okay, so that's my apple. Let's do the phone. Oh, that's got it. Oh, it had like 100% cell phone. So that's pretty good. It recognizes a cell phone really well. But this is a point that I want to make here. I'm going to turn up the brightness because that was like, it was hard to see, right? For us to be able to see. Now I'm going to hold up the apple. It knows it's an apple, right? So here we go. Well, if for a second I thought it might be a person. It thinks it's it's grabbing my hand and saying that's a person. Good job, little machine. You know what you're doing. You're learning. Okay, so see, it does a much better job when it's lighter, when it's brighter, when there's more light of saying what the image is. Okay, so I think that it's important because when we're working with these models and if we're trying to put them in production, there's so much that can affect how things are being labeled. Light, blurriness, the quality of the camera can all certainly affect it. There's something weird that was going on with my phone. It was like flashing. Anyway, it looked like it was flashing. So I don't really have anything else. It kept thinking that my light bulb was a banana. I'm not really sure. Oh, it's a hairdryer now. Interesting. And then I was like, well, what if you turn it upside down? A mouse. Yeah, we do have mice in our house. Somebody can set my mouse traps for me. Oh, it's a bottle. That's not bad. Kind of looks like a bottle. And I feel like, I don't know if this is accurate or not, but anytime I put something towards my mouth, it labeled it as food. So it's interesting to kind of see like where, and like if you hold it halfway off screen, what does it label it as? It really thinks it's a remote. But the point is with all of this, however, when you're working with models, you're definitely going to get some things that are inaccurate. You can have really great data for something, but also recognize that your users might not have the best images or the best webcam. And so anytime it thinks my room is a refrigerator. Is it because of my Post-it notes? The point is, anytime that you have something there, it can... I'm sorry, I'm really distracted by my refrigerator. I guess so, like, because it's a corner of the room, so it doesn't think that it's... Wait a minute, other way. It's not really sure, and it's very distracting to me. I'm glad that I did that demonstration with my arms because I'm sure that that really helped you to understand it even better. So you can have a great data set, but you have to remember that when you're identifying things, that sometimes your users are going to have things that aren't the best. They're not going to have the best equipment. And so if your data is perfect, if it is an image of an apple and a white background and just from different angles, that you're not going to get that accuracy or the results that you want to have. So these are things just to be aware of, because if you're just getting into machine learning or you're learning about this for the first time, like me, like, oh yeah, that makes a lot of sense, but also it's not something that I would have thought about unless somebody mentioned it to me. So I'm going to stop sharing that screen. And I just want to say I am sorry that we did not get through everything that I wanted to get through today. I don't know where I ran out of time. Still working on that pacing thing, which is hard for me, and doing all of this stuff together. But thank you to everyone who joined today. I will either finish up this in a second stream or I will write a blog post on it, but I hope that you will join me either on our TensorFlow.js study group on Friday, or you will come back again next Tuesday. So thanks, and I hope you have an awesome week.